Hello and welcome to this first in a series of videos about cyber resilience and the work that CAM Testbed UK is currently undertaking in this area. Secure systems are a fundamental building block of any connected autonomous mobility system. And today I'm joined by Peter Davies from Thales, who's leading one of our interoperability projects on cyber resilience. Welcome, Peter, and thanks for joining us today.
Thanks very much, Francis.
Can I start by asking, why do we use the term cyber resilience in the environment of connected autonomous mobility?
Well, obviously people are very familiar with cyber security and things of this nature, but over a number of years now, looking at on many of the predecessor pieces of work that we've done on CAVs and looking at how they work, it's become obvious that the real challenge is to achieve resilience. So the long-term ability of a system to actually do what you want it to do, and to do that in the face of cyber attackers, but actually to do that anyway is really the critical thing that we're looking at there. So we've looked at cyber resilience, partly because the ability to achieve that requires new ways of looking at engineering. It required new ways of behaving as organizations. It requires changes to the regulatory framework and to the legal frameworks that we sit around on, that sort of stuff. But we won't be able to actually take the thing forward if we cannot guarantee over a long period of time, or at least give adequate assurances over a long period of time, that things will behave as we expect them to do and do what they need to do over that period of time. So that's why we go for resilience rather than particularly looking at security. And one other element there, the resilience thing has this aspect of, as opposed to many security frameworks which are looking at really quite static things and really don't fit well into some of the cyber environments, what you have here is a really dynamic environment. You have vehicles connected to vehicles to infrastructure. You have AI systems. You have a really complex system that fits together. And in those environments, you expect, and we will expect, that there will be emergent properties. There will be emergent things that will be very valuable to us as a society. And as for each of the players in relation to that, we need to be in a position to embrace that emergence as part of what we're doing, and that has to be part of the resilience. So those combined things, if you like, are why we talk in terms of that. So with that, we'll be able to do something that is useful on the long term. Without that, I think it will be very difficult to realise some of the investments we've already made.
Thanks, Peter. Can you describe for me then what the main aims of our project are?
So I guess, as I was starting to say there, we started this journey 6, 7, 8 years ago, by looking at various things. We looked at vehicle-to-vehicle comms, and over that period of time, we've been through a process of identifying what the problems were, identifying how these things would likely collapse, identifying the science that sat behind those sorts of things, and worked forward so that by March of 2020, we'd identified a methodology, we'd identified a set of principles and arguments that you would need in order to be able to take to court the types of things that you would want to do in order to satisfy the public, in order to satisfy yourself, and to be in a position to be in a position effectively to do engineering, which is what we need to do in order to get the kind of certainty that you needed to do on those things. And with some assistance from yourselves, Zenzic and Innovate and CCAV, we proceeded to go through that and demonstrate the technological and economic feasibility of actually doing that. And that was a really important thing to do. So this next step, which is, if you like, the next step on that journey, was to actually demonstrate what would that look like, for the different players in this sort of thing, and essentially how could we set up tool chains, how could we do this, and what kind of business processes would that mean that we would need, and would that enable in the OEMs, in the tier suppliers, within the regulators, what would we actually need to see, and how could we support all of those sorts of things. So being very conscious that what you were looking at is complex cyber physical systems, looking at exactly how could we put these things together. So that is essentially what we were trying to do in relation to that, and how we've been trying to move forward. And we've been doing that by essentially setting up a demonstrable tool chain, a set of things, and a framework into which people can put additional things. So we can put additional academic outputs and things of this nature coming into this.
Okay, thanks very much, Peter. Could you just go on then to maybe describe what the main components of the project are and how they integrate together to deliver what you've just described?
Yeah, so that was one of the big challenges, and obviously we often see a little bit that does this or a little bit that does that goes that, and at no point have we been saying that many of the techniques that we have, or much of the research is valueless. It's not that, but we have been saying that it needs to be used in the right places, and that if you don't use it in the right place. So in order to achieve what we were looking at, and in order to make this something that people could get closer so that it could be adopted, we essentially based this around a distributed ledger, so blockchain set of things. With this having the characteristic that you can put things in there, and you can put things in there from intelligence databases, you can put things in there, for the software updates that you're doing, and you can put things in there from the decisions that you're making. You can essentially keep that as an element, as the core of what you're doing. And our idea here was that ledger can operate at the level of every vehicle, if you like. So it's not that it's on board every vehicle, but it's there as a record in relation to every vehicle for what you're looking to do. It's able to record not just the digital changes that we make, but it's quite capable of therefore recording, I have made no changes to this vehicle, but it's behaving differently, which is your key to go looking for environmental changes and things of this nature. So what we have done for the first time is try to start to address some of these elements about it doesn't matter where it comes from, we have to actually know about those sorts of things, as opposed to the if you like more digital centric sorts of things that you got from conventional IT systems. So this is a complex IT cyber physical system. We've built into there tools and techniques that are designed to be able to recognize things that are following the principles that we've been talking about. So one of the principles was you must be able to recognize events. So we looked for not just how can I recognize events that are inside my model, if you like, which is the normal engineering process. I've got this thing here, I understand this, but also how can we recognize events that are outside of our model? And we have tools and chains that are looking and examining what's happening on the physical side to look at those sorts of things. We've combined that with a tool that's looking at how do I do real-time VMV? How do I look at this on a real-time basis and look at candidate cases that might, if I discover there's a problem, that might actually be able to overcome this. And therefore, and we record this information, we record the thinking about why we do those sorts of things into this distributed ledger. So we've seen these changes, or we've got these, we've done this VMV that goes with that kind of stuff. And then what we've tried to do is start to use some of the data science tools and things that we would want to use. So we've majored on one set of capabilities that's based around Lyapunov exponents, which is essentially looking at what is the stability of the system. And another that is looking at Jacquard coefficients and things of this nature, which is looking at how much significant difference have you got into the. And the idea here is I've got enough difference, I've got a stable enough, I've got the justifications, and I can record those into the distributed ledger for why I should be able to update a piece of software. And I'm recording this in real time and creating a tool chain that will essentially do a feedback loop to allow us to put this sort of stuff in there, because we perceived from a resilience point of view and from a cyber security point of view, one of the really big problems we were looking at is you can't operate at the scale and at the pace that you would need to do so. So this was designed to look at, we could put these things in here, we could do these things, we could have these elements there. So the other two parts that we have coming out of this tool chain that we've concentrated on are, firstly, is that evidence that we're recording suitable to be taken to court? And we're very grateful for some really good legal input that we have on this one. So can we use this, and would that be something that you would expect to take to court? Remembering that oftentimes what you do is actually try and generate this stuff after the fact, and we don't really have experience of doing this. So preparing evidence on a per vehicle basis to be able to justify the courts. The second thing we then had on that side of it, if you like, was looking at how would we be able to, to respond to the needs of the regulators in relation to this. So the regulators have a really tough job in relation to this. The public expects them to regulate, to give us these things, and you need positive outcomes, and we need to fit in the international environment. So we're looking at, if we're able to record this event, if we're looking to do this sort of stuff, are you going to be able to trust that enough that it will fit into your regulatory obligations? Will it do the sorts of things that you need in relation to that? So the absolutely key thing here is trying to give the regulators options and make it clear that we could do that kind of stuff. And I guess that's how we put the tools together to try and push those things together.
And finally, who is the project aimed at, and how will they benefit from this project?
So it's aimed at multiple people and multiple organisations in relation to this. So many of our colleagues in the automotive industry have looked at the work that we've done, and that's been in the UK, but it's also been worldwide, and has said that's great, but how would we do that? And that's in two areas. So we've had that coming from the engineering teams, but we've also had that coming from the management teams in relation to that. And we've had that from the OEMs, from the tier suppliers, from all parts of that supply ecosystem that went in relation to that. So one of the purposes of this is to answer for those organisations, how would this fit? So we've selected different types of OEMs, so at least 3 different types to look at different characteristics there, to look at how would that fit into your operations, your existing operations, and how would that work for you, and what kind of business change process might you need in relation to that? And for us, that's a really important thing. The automotive industry is an extremely refined industry from a cost point of view to achieving its outcomes. And you break that at your peril. So working out a way to do cyber resilience into that isn't a matter of telling somebody how they need to do a lot of other things that they don't. It's a matter of working a way that can be feasibly fitted in. So that's one of the things that we've set up these tools to try and explore that, to try and help people to do that. Second outcome is for the academic community. They come up with so many good elements, so many good tools, but they can't be used because they stand alone as particular elements. So the idea here is to create a framework into which all these innovative things that we come out with in the UK, all the things that we come out with from our academic partners, can be put into this and can be used. And that's not just a matter of, hey, I'm trying to find a way to do that. There's a huge interest here in making sure that we can create a diversity in the tool chain, rather than everybody does the same thing with one tool, which in itself will be a compromise on the resilience. The third set of things that we're looking at in relation to that is the legal element. So how would this actually fit in relation to that? So more of the business side of some of these things. So what are my obligations? What have I got to say in relation to that? And trying to show people that they're not taking a risk in relation to this, and really to juxtapose that against some of the systems that we're at risk of putting in place that really can't scale. So trying to give people a way of actually starting to explore this in their own organisations and understanding what this might look at. A very important one is obviously the regulators. And I think actually in talking to the regulators, again, this theme of scale comes back in relation to this. So if you were telling me that what we had to do was actually look at every vehicle on everything, and we were looking, I think our stats show you were expecting 250,000 cyber attacks, over an 8-year vehicle lifetime, with complexity being the biggest problem you have. So in that kind of context, and in a context where every vehicle may be a problem in its own right in relation to that, what scale of enterprise would you need to regulate that if we do it in the way that we're doing it at the moment? So this bit of looking at how can you lean on these things, how can you lean on some of the tools? And the final one that we really wanted to look at, so it's a platitude, people talk about 250,000 plus shortage in skills in cyber people, and it's not a thing that we're keeping up with. The intent here is not to do that. The intent is to change the game by saying this is an engineering process. It has to be an engineering process, and it has to be driven by tools. And we need a small number of really expert people who understand how to generate the tools for us, and then we can use the people that we have who are expert in the markets that they want to go into. So we hope it will satisfy that combination of people. And we hope by doing so, it will make things like the investments that have been made in the test beds and things in the UK much more effective, because it will put us into a situation where we can test for volume deployments in a way that actually is cognizant of these sorts of problems.
Okay, thanks, Peter. That's a very, very good and comprehensive introduction to the project. It only remains for me to thank you for today, and thanks for explaining that to people. Thanks, Peter. Bye now.
Thanks, Francis.